Hello, my name is Katharine Cannatella, and this is my Make My Own Physics Lab. Mine is called Friction Matters. My purpose, or my objective, was to examine friction and its effect on sliding objects. In my outcome, I found that friction is often a large force acting on objects that affects speed and distance, and the coefficient of friction is different for different materials. First, we will see in Tracker how I slid a textbook using moderate force across the table. I set the axis so the textbook moves in the positive x direction. I set the calibration stick as 25 centimeters because that's the length of the textbook. My time interval starts right after I let go of the textbook until the textbook stops and lasts approximately 0.9 seconds. My center of mass is the center of the textbook. Next, I slid the textbook across the rug. I set the axis once again so that the textbook moves in the positive x direction, as you can see. I set the calibration stick again to 25 centimeters because that's the length of the textbook. And my time interval now is only about 0.4 seconds. And it starts right after I let go of the textbook to when the textbook stops. My center of mass is once again the center of the textbook. I then went into VPython and coded a system that did not show the effects of friction. I used the mass of the textbook as 0.226 kilograms, and then I estimated the textbook's initial velocity based on the force that I applied at 1.6 meters per second. And I used my delta t of 0.033 from the tracker data. Here you can see my code. Notice that Fnet equals 0, which means that there was no force acting on the system other than the initial force, so friction is not taken into account. As you can see here that I update the position of the ball based on the ball's initial velocity, updating it during each delta t time step. I'm now going to run the module. Notice how the ball just moves in a straight line, and as you can see from the graph, it is perfectly linear. This shows that the ball's velocity does not change, and if it went on forever, it would never stop. These are the Excel sheets of all my data. On the right, you can see the data from Tracker that did not take into the account of friction. Notice how on the graph, the line is perfectly linear, and the r squared value is equal to 1. This shows that without friction, ideally, an object would keep moving continuously until another force acted on it. On the left, you can see my distance versus time graph for the table and my distance versus time graphs for the rug. As you can see, my r squared value for the distance versus time graph of the table is approximately 0.947, and it tapers off. Eventually, the textbook on the table came to rest at about 0.7 seconds and went about 0.1 meters. Now, if you look at my graph for the rug, you can see that the textbook stopped moving at approximately 0.35 seconds and only went 0.07 meters. The r squared value for this graph is 0.94. This displays that there was a higher coefficient on the rug than there was on the table. In this lab, I found out that dry friction, or the lateral friction between a moving and a non-moving object, was acting on the system both with the table and with the rug. It was not acting on the system that I modeled in VPython. We also found that the rug had a higher coefficient of friction because it slowed down faster and went a shorter distance when approximately the same force was applied to it. I also found out that the direction of the frictional force was opposite the direction of the force I applied and caused both objects, both on the rug and the table, to stop.